Welcome to EDU World Space.
So if we use the expression from problem 27, that the angular momentum of a system of particles about the origin O is equal to the mass center for that system r bar cross with the momentum of the center of the mass center m v bar, where v bar is the velocity of the mass center, plus the angular momentum h about that mass center g. So this expression we've shown already. If we take this expression and differentiate one time with respect to t, we get the following. HO dot is equal to r bar dot, which is essentially dr bar dt, crossed with mv. So we essentially will use the product rule here. So that's plus, we leave r bar cross m v bar dot plus the angular momentum about the mass center differentiated with respect to time. So we end up with this expression. But we know from equation 14.11 that h dot, the time derivative of the angular momentum, is simply the sum of the moments about the origin, sigma mo. And so sigma mo is equal to r dot cross mv plus r cross mv dot plus h dot about point G. So let's simplify this expression. So r dot is basically the r dt, which is v bar. So that's v bar cross m v bar plus r cross with m, and v dot is simply acceleration, dv dt. The rate of change of velocity is the acceleration. So that's ma plus, and we leave this term as h dot around g. So we can simplify this even further. So v cross v is 0, and that's plus the mass center r cross with ma, which is defined as the sum from I going from 1 to n of the force, or the resultant force acting on each particle, Fi. From Newton's second law, m times a is F, and then plus our angular momentum term, h around g. But what we do know, we know that the sum from I going from 1 to n of the moments about the origin, mo, is equal to the sum of the moments about the mass center, mg, plus the sum over I from 1 to n of r. Actually, there is only one mass center, so this is plus the mass center r bar crossed with the sum I is going from 1 to n of the forces acting on each particle, Fi. So we know this is true. So if we compare this to the equation above, we can see that we can replace h dot with sigma mg. So If we subtract r cross sigma Fi from each side of equation 1, we get, this is our equation 1, if we subtract r cross the sum of the forces from each side, we get that the sum of the moments about the center of mass, sigma mg, is equal to the first derivative with respect to time of the angular momentum of the system about that center of mass.